Now, a second method we can use for solving is called the square root property. And we actually kind of did some of this in reverse. This has a very limited use, and we can only use it if an equation is of the form ax squared equals c. Notice there's no linear x term. So then basically we can isolate the x squared term, take the square root to undo it to solve. Key. Remember I just said if you have a square power, if you're to the second power, you need two potential answers. So when you take the square root, remember you get positive and negative answers. You cannot, if you have something like x squared plus 4x equals 10, you cannot take the square root of both sides and simply say x plus 2 something. So remember, we can't take that square root across an addition problem. So that doesn't work. But where it does work are problems like this. Notice I only have an x squared. So I'm going to add 6 to both sides. R squared equals 16. Take the square root of both sides. R is plus or minus 4. And there are your two answers. Here, what's in the way of x being by itself is 8. So I'm going to divide both sides by 8. So x squared is 60. Like I said, x squared equals 61. 8 goes into 488 61 times. Now we're going to take the square root of both sides. And we have x is equal to plus or minus the square root of 61. Do some checking, make sure that 61 doesn't have any perfect square factors. If it doesn't, it is the exact answer, and you don't need to touch your calculator. This one looks very complicated, but we are going to use our basic algebra skills to get n squared by itself. So first I'm going to add 5 to both sides. So I have negative 7n squared is equal to negative 693. I'm going to divide both sides by negative 7. And so n squared is equal to positive 99. We're going to take the square root of both sides. We're going to get n is equal to plus or minus the square root of 99. Now the square root of 99 is not in simplest form. We know that that is really equal to 9 times 11. And so n is equal to plus or minus the square root of 9 is 3. Radical 11 is my leftover. That is your exact answer. So when you can apply the square root property, it really speeds up the process, but it only works when you only have a variable squared. You cannot have that variable as part of the problem also. And now our favorite. This is review. We have talked a little bit about the quadratic formula. Remember, it goes to the Pop Goes the Weasel song, but I won't torment you now. But it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And remember, those a's, b's, and c's come from that standard form that we've been dealing with, that we pull coefficients only off. Now, quadratic formula always works. Always, always, always works. Sometimes you cannot factor a trinomial down to its pieces. Then you have to use the quadratic formula. If it doesn't factor, you have to use the quadratic formula. If it factors, I usually factor and use zero product property. But know that quadratic formula will work even if it factors. You still always need to make sure that you are in that standard form equal to 0 before you start. And you will always get two answers exact answers are best. So you now can handle that radical piece as a radical and give it an exact form. So let's look at some examples. So 3m squared minus 4m minus 64 equals 0. If it factored, great. If it doesn't, I don't know. Don't care at this point. We're going to say that a is 3, b is minus 4, and c is negative 64. If it would have factored, when we get all done, we'll get whole numbers. If it wouldn't have factored, we'll get fractions. So we've got the opposite of b. Now remember, if I start with a negative, I have to still make it minus. Plus or minus, that takes care of my two answers. The square root of negative 4 squared b squared minus 4 times a times c, all over 2 times whatever a is. Now make sure you get that fraction bar continued all the way to the end. Sometimes this first opposite of b term gets left out of the fraction bar. Now it's a matter of cleaning it up. So the opposite of the opposite, I've got 4 plus or minus the square root of 16. Watch that sign. Fancy calculators, remember to do that. So now I have 12 times 64, two negatives make a positive. So I have plus 768 in my numerator, all over 6. Add underneath your radical, and I have 4 plus or minus the square root of 784, all over 6. Now I need to go about using my reducing radical skill. I'm just going to go over here off to the side and do my factor tree for 784. So 784, I know there's a 2 in it, 3, 9, 2. I know there's a 2 in it, 1, 9, 6. That's a perfect square, isn't it? 196. And so what I have here is 4 plus or minus the square root of 2 squared times 14 squared, all over 6. So I have 4 plus or minus the square root, oops, I did to take the square root, 2 times 14, all over 6. 4 plus or minus 28 over 6. Now I have two baby problems that result of this. I've got 4 plus 28 divided by 6, or I have 4 minus 28 divided by 6. So this is 32 divided by 6, and this is negative 24 divided by 6 is negative 4. Reduce your fraction. These have a common fraction of 2. So my answers are 16/3 and negative 4. Now, that's a lot of work and it's a little putsy, and that's why if something factors, you may want to work on your factoring skills. So let's look at another example here. This one also needs to be simplified, so I'm going to put into proper form, so I'm going to subtract 12 from both sides. So I have 5v squared minus v minus 130 equals 0. So a is 5, b is minus 1, c is negative 130. So quadratic formula, the opposite of b plus or minus the square root of b squared minus 4 times a times c, all over 2a. So now it's cleaning up. 1 plus or minus the square root of 1 minus a minus is plus. 1 plus 20 times 130, 2060 or 2600, all over 10. Move this guy out of the way. I have 1 plus or minus the square root of 2601, all over 10. I'm pretty sure that doesn't have any perfect squares in it. And that is your exact answer. Let's do one more example. We're going to do this one over here. You can do this one on your own if you want. We're going to work this one over here. Now, this is a big mess. So I'm going to add 7k to both sides, and I'm going to add 9 to both sides. This will give me 6k squared plus negative k minus 70 equals 0. So my a is 6, my b is negative 1, and my c is negative 70. So quadratic formula. Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I have 1 plus or minus the square root of 1 plus 70 times 24, which is 1681, all over 12. So I have 1 plus or minus the square root of 1682, all over 12. Now find some paper. Let's check. 1682 obviously has a common factor of 2, 841. When we get to this point, do some checking. I'm pretty sure 841 doesn't have any common factors, any perfect squares. So this is actually in lowest terms. And that's what happens sometimes when your numbers get very big. We have time. We can work one more example that might be a little easier. This one, we just need to add 3 to both sides. So I have 6n squared plus 4n plus 3 equals 0. So a is 6, b is negative 4, c is negative 3. So the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I have negative 4 plus or minus the square root of 16 minus 72 all over 12. And this is an example of where you then have an interesting occurrence. The piece underneath the radical is negative. And we know at this point you cannot take the square root of a negative number. So when that happens, you're actually done. And your answer is no solution. There are no factors. There are no solutions to this equation. No x's, no n's when the y is 0. So if you get to a point where you can't work the problem anymore, which happens if you get a negative under the radical, then you are done with the problem. That is the extent of the lesson. Good luck, and I'll take questions on Tuesday.